Assalamualaikum warahmatullahi wabarakatuh. For today, I will present my scientific paper that titled is Improving Data Privacy on Online Social Networks Using Blockchain and Decentralization Accessible Networks. So the first, for the abstract, what is the background that I choose this title? First of all, online social networks or OSN is a service that can be used to interact and share information with other online. Currently, many OSN service providers are collect various important information such as personal data and other sensitive data centralized. This can be threat to user privacy, especially related to the leakage of user data to other parties without user permissions. Various researchers has proposed the concept of decentralization on OSN, commonly decentralized online social networks. This architecture is believed to provide better privacy for users by removing centralized alteration from OSN service providers. User data will be spread across multiple servers to fully distributed on user devices on peer-to-peer networks. In this presentation, I will discuss the use of storage privacy services distributed and decentralized concept on the online social network that can improve user privacy. In addition, it will discuss access control, blockchain in decentralized online social network can solve issues trust and data integrity. The method itself, by improving user privacy through blockchain application and decentralized online social network. And the result that I can get is the problem can be solved with the blockchain application in decentralized online social network. And for the conclusions, a centralized online networks or OSNs architecture allows providers to the service has full access and control over all users' data and information. This, of course, can cause problem especially related to user privacy. This problem can be solved with decentralized online social architecture network or USN. USN can improve user data privacy by providing more access for users to manage their personal information and use cryptography on existing information. Introductions. Online social networks have become an important part of activities of many internet users. Through USN users can share moments, photos, videos, and quotes or posts with their online friends. One of them One of the platform is Facebook. Facebook, as the one of the largest OSN platforms in the world, claims there are around 2.45 billion active users in end of September 2019. These users have more than 125 billion friendship connection and can generate 3.2 billion likes and comment in a day. There are also various other SN platforms such as Instagram, Twitter, and others, which have attracted billion users of all age, culture, nationalities, and backgrounds. In general, USN provides storage services that can be used to store users' digital information. In addition, OSN also connect user with other users into the networks. Most of the information, including personal information, is stored centrally by service providers, who may at times collaborate with third parties and use this information for various purposes. Service providers can also share or sell user information to other parties who do not use regulation related to data privacy. This can be lead to the leakage of personal information on social media or various other internet services, which can result in identified theft, fraud, or anything else. In the methods, I will explain blockchain structure, mechanism, and scalability. Blockchain is one of technologies that are of concern to both academics and practitioners today. This blockchain technology underlies the information of Bitcoin, which was the first implementation of cryptocurrency. The initial design of the blockchain was first described by Satoshi Nakamoto in October 2008. Blockchain is basically digital transaction record, commonly called ledger, to, to record a transaction and is distributed in decentralized manner. This ledger will be managed simultaneously on a network of device called nodes, and these nodes can be active in any electronic device, including computer, mobile phones, or even an IoT or Internet of Things device. In general, a node is free to participate or leave the blockchain network and validate, and synchronize, and keep full copy of the ledger. Each node has the same position, so there's no master or central node that manage other nodes. Here, as you can see, this is a blockchain ledger structure. So the basis from the picture, a structure of a blockchain ledger can easily describe as a chain of blocks where the transactions are recorded. Each block will be connected to the previous block except the genesis block, which is the first block of the blockchain. Due to this, any transaction involved cannot be retroactively modified without change entire associated block. In order to reach required agreement for in each transaction, the blockchain implements a consensus mechanism among the nodes on the system. Each node will periodically complete to win the rights and to add new transactions to the blockchain. Through a consensus mechanism, the blockchain can decide on a winning node, and once it's determined, selected node can add blocks to the blockchain ledger. Blockchain use cryptographic techniques to protect user personal information. The user account will be expressed in the virtual addresses generated by appropriate public key, and because of this, a blockchain is considered untraceable and completely anonymous system. However, some studies show that it is possible to track user personal data information through proper network analysis. As a result, several approaches has been proposed to overcome the anonymity of blockchain systems. And for current limitation of a blockchain, such as low throughput, high latency, and resource exhausting, have led to increased public attention related to blockchain scalability in industry and academia. To handle limitation of the blockchain, sharding technology is considered one of the most promising solutions to solve blockchain scalability problems. Sharding technology is originally referred to database scaling approach, which was later used on the blockchain by National University of Singapore. Sharding on blockchain will expand into several sub-blockchain that can be processed in parallel so that horizontal scalability is achieved. As a result, several researchers have analyzed the implementation of blockchain in the OSN. One of them is Zhang, Y1, and F1. Then propose the DSS system architecture that uses blockchain and the concept of sharding to solve the problem of trust between nodes and efficiency of blockchain performance and performance. So from below picture, it can be seen that the proposed DSN architecture has three parts consisting of one, communication network, blockchain network, and social network. And to improve user security and privacy, they also propose the concept of reputation-based authority control, which would limit user access in the system based on their reputation in the OSN. Jiang and Zhang proposed the concept of BCOSN, or blockchain-based online social network architecture that use blockchain and smart contracts in contact to increase the efficiency of access control and ensure trust between transactions. To increase user privacy, the BCOSN architecture will also use encryption-based access control. Any data added to the blockchain will encrypt it first, and only people who have access can open the data on the blockchain. According to S. Zhang, Y1, F1, and also L. Zhang and X. Zhang, the use of blockchain on the OSN will have the following advantage. First, blockchain can guarantee all node transactions without the need for a third party or supernode that given more authority. The use of blockchain will ensure that the relationship between nodes can be trusted so that the OSN architecture is optimized. Second, the use of blockchain can avoid a single point of failure. This is because the blockchain network is distributed network, so the failure of multiple nodes will not cause the DOSN failure. Third, blockchain can allow users to store and receive information without fear of data falsification. Without blockchain, it would be difficult to ascertain whether data is not been modified and OS has not been deleted on the OSN. But however, the implementation of blockchain in the OSN has also have some limitation, including security of the blockchain also needs special attention. If the majority of the nodes are contracted in a group, then that group can attack the blockchain and connected application, and commonly is called a 51% attack. However, this attack has a very high cost, and have been several studies that have tried to deal with this problem. And currently, the costs required to implement the blockchain on the OSN are still quite expensive, especially if the OSN architecture implement blockchain on various exciting platforms. Blockchain deployment will be more suitable and implemented on a completely independent network built for the OSN application. This independent network will allow the OSN node tailor to blockchain to their needs at lower cost. And for the conclusions, the centralized online social network or EOSN architecture provides service provider to have full access and control over all user data information. This course can cause problems especially related to user privacy. This problem can be solved with decentralized online social network or DOSN architecture. USN can improve user data privacy by providing users with more access to manage their personal information, use of cryptography, and exiting information. Additionally, this architecture can remove the centralized authorization that OSN service providers have of user information through distributed storage mechanism. However, DOSN has still many shortcomings, such as the difficulty of establishing a trusted relationship between nodes and difficulty of ensuring data integrity without trusted third party. This can be overcome through the implementation of blockchain in the USN architecture. The use of blockchain can guarantee all node transactions without need to a third party or authorized supernode. In addition, a blockchain can avoid the occurrence of single point failure and allow users to store and receive more information without fear and data falsification. Thank you very much. I will end this presentation. Assalamualaikum warahmatullahi wabarakatuh.